Hi, welcome to my talk. Thank you for coming. My name is Benjamin Ritter. I'm working for Scandio GmbH. I'm doing IT consulting, mostly around cloud native and Kubernetes. That's how you can reach me. So we're talking about GitOps, so there's a short introduction for those of you who can't remember what it basically means. It focuses around version control and using CI/CD tooling to do infrastructure automation. And when we're talking about GitOps, we're also going to talk about secrets. So we need to store them somehow. So basically, this is our workflow. We have a Git repo. We deploy it via a CD pipeline. In our case, I'm familiar with Argo, so all of my examples will be centered around Argo. And we deploy it into a Kubernetes cluster. So we want to provision these secrets. Those can be credentials for API services, for databases, certificates for TLS or whatever. And you should not store them in clear text. And we want to be able to move secrets through our deployment process, even if we don't trust certain elements of our deployment process. Specifically, we are talking about Git repos, so there are a few disadvantages of having clear text secrets. You have to guard your repo. So you can't use it as a ad hoc documentation for your consumer teams. They can't put up pull requests to enable features for them, for example. You will always have to fear accidentally leaking secrets. And also, this might be a little bit more subtle, but every developer working with your Git repo will have a copy of production secrets on their local machine, which is a bit of a security problem. So we're talking about transport security for those secrets. And like side objectives here are forward secrecy, so what happens when someone leaves the company and you don't want to leak the secrets that way, and you don't want to rotate, although you should probably rotate your secrets, but nobody does, let's be real. You want a certain degree of runtime security, so you want to make it hard to extract secrets in a normal working cluster. You want encryption at rest, and maybe some aggressive rotation schedules. We're talking about like hours instead of years. So what are Kubernetes secrets? Why do they not suffice? They're API objects. They're stored in the etcd. So they can be queried with like normal API calls. They are not encrypted. They are just base64 encoded. You can treat them as config maps. They are basically clear text. So we can't treat them as a security device. So we need to handle them somewhat else. And this is like the problem. We put our secret in our Git repository where it is vulnerable. We deploy it via Argo CD. And yeah, that's basically what we're working with here. So there are a few strategies we can use. We can first handle our secrets manually out of band, which is like, I'm not going to talk about this, by the way. We can encrypt the secrets and store them in our version control and decrypt them in a cluster. We can provision the secrets in a secure location. Think AWS Secret Manager, think Key Vault, think Hashicorp Vault. And the third one, we can utilize some deployment patterns that make explicit secret management unnecessary. A few examples of this for the version control encryption thing is Bitnami sealed secrets. The other one is external secrets and its derivatives. And the third thing are cross-plane database operators, IAM service accounts, and ACME. So we are going to start with Bitnami sealed secrets. By the way, just, this is an overview talk. I'm not expecting you to run out and be able to provision this like after this talk. You will probably have to do some Googling and figure this out. But just that you have an overview of what's going on and what are the tools you could begin to learn and to use in your projects. So we're starting with Bitnami sealed secrets. It's an operator. It runs in your cluster. There's a controller running on your cluster. There's a CLI you can use in your deployment pipeline on your local machine. That kubectl CLI asymmetrically encrypts your secrets and then gives you a sealed secret resource, and you apply that to your cluster. Your root of trust, in this case, is the etcd of your Kubernetes cluster. So if your threat model includes compromise of your etcd, you probably should look for something else. Key rotation is done by the sealed secrets controller. If we're talking about rotation, we're not talking about like rekeying the secrets every so and so often, but there will be a new key generated every 30 days. So you have some sort of forward secrecy here. even if you revoke access to your clusters. So basically, you create your secret resource, you seal it with kubectl, you apply the sealed secret resource onto your cluster, and then you get your secret back. If you're doing this in like a one-liner, or I guess five-liner here, it looks something like this. You create your secret, you dry run it, so it won't get applied to your cluster. You kubectl it against the cluster you're working in. It's using the cluster that is currently the default cluster in your context, and then you shove it into a file, you apply that via your GitOps pipeline, and you should be good. A sealed secrets resource, by the way, looks something like this. It's basically a bit of metadata and the content of the original secret, which is encrypted. I don't know if you speak like elliptic curve cryptography, but it's encrypted. So this is basically what it looks like. You seal it, you get like this resource. This is, by the way, not Kubernetes. This is like not on the cluster. This is how this encapsulation works. And then there's this pipeline. You deploy the thing that's on the right here, and you apply it to your cluster. The sealed secrets controller picks it up, encrypts it, puts it in the etcd as a normal secret. So a few notes there. You will always seal against one cluster. You will not seal against multiple clusters. Every sealed secret is specific to one cluster. So if you have multiple clusters, you have to reseal them against every individual one. Editing the sealed secrets will require resealing. This sounds a little bit worse than it actually is. You can do it in a one-liner. And the one thing that it differentiates this one from most of the other solutions we are going to talk about is we don't have any external dependencies. So you can bootstrap with this solution other solutions, for example, and don't have like a step where you have to be like, oh, now is the part where I have to like copy-paste credentials from one place to another and kubectl apply them. So yeah. The next one we're talking about is the external secrets operator. Its main thing is it takes secrets from a secret location, again, AWS, Secret Manager, Hashicorp Vault, and it syncs them periodically into your cluster. There's a mechanism there. It uses a secret store. This is like an abstraction. We'll take a look at this one. You create external secrets which references this key in your secret store, and then external secrets, I'm so sorry, will sync it to your cluster. This is a bit how it looks like. You have your credentials in your secret stores. It's another secret. You can provision that one with Bitnami sealed secrets, for example. It takes the AWS credentials, goes to the cloud, to the AWS Cloud API in this case. It extracts the password. It writes it to a password secret, and managed by the external secret custom resource. This is what a secret store looks like. Again, reference to an existing secret, which is allowed to extract these secrets from a key store. This is what an external secret looks like. You reference a secret store. You want your stuff written to a target, and you could do like some swizzling there between key value names, basically, and you extract the data from your key store, and you're good. And then it will provision your secret. One thing you might notice, line 6, it's polling. It's a polling system, so it will not be event-based. If you change your secret, there might be a delay in it propagating to your clusters. But you can like lower this, but you might run into API limits. Okay, so challenges for external secrets. Again, how do we get the secrets into the credentials into the secret store? You can do that via IAM roles. You can do it via credentials. You will still have the problem that your secrets are stored on the etcd, and secret refresh is only done by polling, so no event-based things here. You probably won't be able to rotate your database passwords every hour or so and not experience any delays here. And you will be limited by the Kubernetes permission system, so scoping below a namespace scope will be a little bit difficult here. So very, very similar concept, but a little bit different in design. The secret store CSI driver, it basically does the same thing as the external secrets operator. It takes your secrets, it mounts them into a pod. But it will not write them to etcd, so extracting them will basically involve an exec call, which you can audit for a little bit better with like kubectl run. You can audit that a little bit better than like a kubectl get on like secret resources, so you probably have less noise doing it this way. if you're really concerned about this stuff. It works basically the same way, but it's just a little bit different names here. You have a provider source that where you provision your secret. It posts the secret into your cluster, and it mounts it into a volume in your pod. Vault, this is the Vault's agent sidecar injector. This is something to do with Hashicorp Vault specifically. You annotate your pods, it will get the secrets mounted into the pod. The thing that it does a little bit differently is it uses service accounts, and you can authenticate via service accounts, like Kubernetes service accounts, with Vault. So there's a little bit tighter permission management there. And yeah, specific solution, if you're using Hashicorp Vault, this might be an idea. This one will get updated. So if you update something in Vault, there will be an update almost instantaneously into your secrets that are mounted to your path. OK, now we're getting to the interesting part. Until now, we talked about like how we secure credentials. And now we're talking about how we remove credentials from our workflow. Examples for this are the service operators. So you basically remove external provisioning of resources mostly, and you move that provisioning of external resources into your Kubernetes cluster. Examples for this are Crossplane and the Zalando Postgres operator, which Zalando, it provisions a Postgres cluster in your cluster, generates passwords, and writes them to secrets. Crossplane, similar thing, but it does not provision for the resources in your cluster, but it will provision them on an external system. You need permission, like credentials for that, but after that, you basically don't have to worry about application-level credentials anymore. It removes secret handling entirely there, except for bootstrapping it the first time. But reduces your surface you have to manage, so that's a win in my book. It feels a little bit like cheating because you're moving your credential management and your trust for your external applications into your cluster. And you deploy from your cluster to external systems. It worked well for Argo CD and makes like secret management a lot easier. You don't have to have like high permission credentials lying around your outside your cluster. So yeah, you might be able to do that, but it requires a little bit flexibility on an organizational side, and on-prem it might be a little bit difficult to do it, since you might have database teams and they might not appreciate your effort to host your own databases there. This is approximately what it looks like. There's a cluster with Crossplane. There are a few more components, but this is very simplified. You create a custom resource in your Kubernetes cluster. That custom resource is the source of truth, which provisions out a database on Azure. Then it writes the secret, the connection secret, which is automatically generated by Crossplane, into the Azure DB credentials secret. This is a normal Kubernetes secret, by the way. There will be a feature which is currently in alpha, I think, which allows you to use external secret stores externally. So we're going full circle here, where you can use something like AWS Secret Manager, and then you consume that secret via your application, and you notice there's like no second hop for like secret management there. The other thing you can do is you can avoid provisioning credentials by using service accounts, which basically means you have some sort of identity in your workloads, and that identity allows you to access external resources. What Vault does is something like this. It's an example of it. But another example would be the IAM service accounts for AWS. You will have to be a little bit careful there. You trade credential management for policy management. So pick your poison. But you probably should, since it's a little bit harder to mess up and to leak credentials here, since an identity is not as useful as credentials, which can probably, if not properly configured, be used on an outside of your cluster. Okay. So next thing, this is like a very low-hanging fruit if you can. Cert Manager and Acme. If you're using, just as a refresher, Cert Manager is a thing that basically does certificate, especially TLS certificate management for Kubernetes. And Acme is an automatic protocol to provision certificates, and there are protocols in there which allow you to prove that you own a domain. like this, you can generate publicly valid certificates with Acme even for free. Let's Encrypt as an example, but there are paid services that have SLAs and a little bit better API limits. It provisions the certificates, it renews them automatically if they're about to expire. You can monitor that, so that's also very cool. You can get like, you can write a Grafana/Prometheus query to monitor for certificates about to expire that, for example, fail to renew. You can use it with private CAs, and you might have to use that actually in the future because Chromium, the Chromium project, currently, or a while ago, pushed for limiting the maximum duration for certificate validity, like end-user certificate validity. They pushed for it to lower it to 90 days from 365 days, which might happen in the future, and then you probably are forced to automate this, which was, by the way, their intention. So if you're currently provisioning certificates non-automatically, you might want to look into that. If maybe your provider already supports it, the one you're using to provision the certificates, maybe don't, then you might want to think about switching providers. If it's a publicly valid certificate, it really doesn't matter most of the time. So if you want to rotate your secrets during runtime, now we're getting like back to normal secrets, not certificates anymore. If you want to rotate your secrets during runtime, you have to mount them as a volume or use something like the Vault CSI driver. No, it's not the Vault CSI, the Vault sidecar injector, I'm sorry. The env from variable, because that's how environment variables work. They will not be updated after pod startup. And if you want to rotate out the credentials during runtime, your application has to support that. So most proprietary applications probably don't, but because it's a little bit of a niche edge case here. But I mean, if your threat model includes for that, you can definitely do that. If you want to integrate any of these solutions into your workflow, you probably don't want to DIY that. Use these solutions, one of these solutions. They're very, very solid. They are tested. They are battle tested. They are used in production. And don't do stuff like subsealing secret and using a Jenkins pipeline to apply it. That's probably more effort than it's worth. Another thing, and I'm looking at Flux here a little bit for like encrypted Helm secrets here. You should probably keep your secret management and your continuous delivery pipeline separate in case you want to switch one or the other, because that's probably a lot more work than you want to do if you, for example, want to switch your deployment pipeline. If you're writing Helm charts and you have a product using Helm charts, expose secrets as secret references. Don't force the user to write secrets in clear text into Helm values, and expose annotations for pods, since that's used by some of the solutions to inject the secrets into your workload. So what should you use? There are a few selection criteria here. If you rotate, how often you rotate your secrets. If you're deploying to multiple clusters, like the same application to multiple clusters, what are your auditing requirements? Are there any legal reasons you need to be able to have a paper trail for secret access, for example? What's your time budget? Of course, if you have like a larger team, you might have a little bit more time to spend on a little bit more sophisticated secret management solution. And your threat model. What can you trust? What do you not trust? And yeah. So, but actually, what do you want to use now? Like, this was very in general, and you probably don't know what you should use. So here are example use cases. If you have a few clusters, if you have mostly static secrets that get rolled every few months or years, depends. You don't have any secret management solution set up, or you want to bootstrap another secret management solution, clearly Bitnami sealed secrets. It's easy to use. It's fast to use. It's like one CLI and a controller in your cluster. It's very nice to use. It's like a Go binary, so you basically can just wget it and put it somewhere, and it'll just work. If you want to share between teams, if you have like an API gateway on one side and like your consuming application on the other side, and you want to transport the secret secretly, just share a secret store, put the secret in the secret store by the producing team, pull it out with like with external secrets or the secret CSI driver. If you have managed external infrastructure, of course. You can use every of the other solutions, but I would recommend looking into the service operators or using service accounts for authentication. You can definitely do that. If you're doing certificates, Cert Manager all the way, it takes so much work out of this, especially if you have like dozens of certificates or more to manage. So thank you for your attention. This was a lot of information, I know. I'll be around answering questions now, and if your question doesn't get any attention, I'm going to be at the Scandio booth at exactly the other side of the convention at the coffee bar. So for the next few hours, so you can ask questions there. How was the time? A little bit short.
Actually, we're doing pretty good. We had a lot of time, which is good because we had a lot of questions.
I mean, I guess so.
Yeah, but also means that the talk was very interesting as well, which is good.
Thank you.
Are there plans to build a recommendation engine? Which part of a program should be optimized and how?
I'm not sure what this question means. Is the person asking that question in...
No, this one is not for you.
Oh, we are on the wrong slide one. Oof.
Sorry, my apologies. Seems like there were questions from previous talk. Oops. My bad. Where are the field secrets encryption keys held? This is one for you.
This is the thing I was talking about with the root of trust in your cluster. They're held in Kubernetes secret resources in the Bitnami sealed secret namespace where it's deployed.
Got it. How can I implement access to custom secret manager with external secrets?
You're probably talking about external, like external secrets has like a set of supported secret managers and like custom
external KMS, for example, I guess.
Like something like KMS, but not KMS. I have actually no idea. As far as I know, they do not have any plugin mechanism. But please fact check me on that and come to me back later. I have no idea if that's possible with external secrets.
That's fine. A nice question also. Have you collected experience with the Vault secret operator?
I did not. I just tried it out a little bit, and it looked sane enough. So, yeah, I mean, it comes with the complexity of Vault, but that's expected. But it looks like a solid product for the use cases. It's it supports, especially like event-based calling of secrets.
Do you think the vanilla secrets resource will become deprecated in the future as a lot of solution on our storage base? Very good question.
I personally do not think that will happen because for a lot of things it is absolutely sufficient. If you do not require any transport security, especially if you're running in your cluster and you expect that your cluster is not hostile to you, you can encrypt the etcd on disk and still use normal secrets. It's just a problem when you try to move across like cluster boundaries. So I don't think they will be deprecated at all.
Got it. Two last question. How does Spire fit in this picture?
I have not used Spire. I can't say anything about that, unfortunately.
That's fine. And the last questions that we have on Slido, why not make the app load the secret from the external provider instead of doing it in Kubernetes?
I mean, it's a fair question. I think the idea is that you can do identity and a certain set of standardization with Kubernetes, which you probably won't do with your application. And even then, like you still have your application. You need to provide identity to it somehow. And if you're using Kubernetes anyway, that's I think a good way to provide some sort of identity or provide it with a configuration environment and make a software that's actually designed for that and audited for that work, make a job, because you don't want to build it yourself.
Leveraging Vault SDKs, for example?
Sorry?
Leveraging Vault SDKs, for example.
Yeah, that's an example. That would be something else. But if you can use it, if you can like do it in a centralized way, you probably want to, maybe.
Any question in the audience? Nope. Nope, you're all hungry. You want to eat.
Understandable. Thank you for coming.
Thank you very much for your talk. A big round of applause.